In this video, I will address the one issue and its solution. The issue is that whenever we make the geometry in a spaceclaim, so for example, here is the heat exchanger, and in the groups we provide the name selections are the names of the boundary conditions. So the problem is that whenever you open this file in the workbench by going to the prepare menu, the workbench menu, and then click on the ANSYS 2022 release 1. Right now this is my version. So this will open the workbench, but the issue is that when you want to take it to the meshing app and then to the Fluent, the name selections they does not appear. And if the name selection does not appear, it means that we cannot provide the boundary conditions in Fluent. So the solution is that either we create the geometry again, or the second thing is that we provide name selection in the ANSYS meshing. The both solutions are not easy to do. Not in the sense that this is difficult, but that it will take some time. So here we are with the solution. So if you right click on the geometry, right now you cannot see any properties. So right click here and click on duplicate. And somehow, I don't know why, but somehow this gives you more options. So here it is only up to the serial number 11. File name, geometry file name, but here we have the 34 fields. This is very strange. Anyhow, so what I'm going to do is that first of all, I will go to spaceclaim, then the file menu, spaceclaim options. And here I will be going through the file options and I will go to the workbench. And you have to, first of all, you have to click on the name selection, it should be selected. And secondly, the name selection key right now is the NS. So I don't know why this name is used. Maybe the name selections, they are right now the boundary conditions here, they have the prefix with the NS, then they can be recognized, but we don't have this thing, so that's why I'm going to delete this from here and click on OK and save file. Okay, and the same file should be updated here as well, right? So, and also you can see that we have the number 19 name selection, so you have to check the point here, and also you have to delete the key from here. So select and press delete. Okay, and now I'm going to use the meshing app on this one. Double click here and we should be able to get the name selections or the boundary condition names in ANSYS meshing app, and subsequently it should be transferred to the CFD solver, like for example the Fluent or maybe CFX. So you can see that we have these all names with us. Okay. Okay, let me delete these contacts also, because I want to show you the same thing in the Fluent as well. So I want to mesh it with the very crude settings, with default settings, and the mesh may not be very best. Okay, so this is the mesh we have right now. Okay, now I'm going to make the connection between the mesh and the Fluent. So here is the Fluent. Okay, also whenever you link to some solver, you have to update the mesh. Update mesh means that it will update everything, including it will give you any errors, and if everything is all right, then it will export mesh to the Fluent or the CFD solver, whatever it is. So right now we have this tick mark is green, which shows that the mesh is now complete, and setup requires the update. So double click here. Okay, choose a number of processors which you have in your computer. Okay, so now you can see that we have this geometry exported, and we do see these all names. All boundary condition names are present. So if we go through them one by one, you can see that we have these two interfaces. We have the wall shell inlet, wall shell left, that is on this side over here, this one, and wall shell outer, that is the outer boundary of the shell. So just hide this boundary, and the shell outlet, which is the wall on the outlet side. This is the right side of the shell. So now I will start with the wall tube left and wall tube right. This is also there. And then we have these thickness regions, that is the solid body between them, that will be used for conduction of the heat transfer. And this is the setup for the conjugate heat transfer. And this is the shell outer. So we have all these walls. So you can also change the colors based on the surface type. And you can also enable the display of outlet and the inlets like this. Okay, and if you want more information like the solution and the advanced meshing techniques and learning and geometry creation in spaceclaim, the simulation, and especially this thing that I have covered in my full course on heat exchanger CFD. So you will get all these things in the course, and I am putting a link in the description. So if you are interested, you can go through that course on the Udemy. So all the theory is covered in the course, and also the basic calculations were covered for defining boundary conditions like the velocity inlet conditions for shell and tube, the temperatures or the heat transfer you should be getting from them, and then the geometry making, then the mesh, and then the second design, which is the modification from the first design, then its mesh also, then third design, fourth design, and finally the fifth design, which is the proper type of the shell and tube heat exchanger with the tubes and baffles. And this is side-by-side comparison. This is the meshing of the fifth case or the full complete case. This is the problem setup. This is the solution. And this is the comparison between all 5 designs. And this is the comparison in terms of the performance. So how much temperature we are getting. And we also know about theoretical temperatures, which we specified. So design 1, and also definitely with the design change, we have the number of cells also changing. Although I try to keep the same size on the same particular boundaries, but if the boundaries are added, then definitely this will increase the number of cells. So shell outlet temperature is 350, and the closest we are getting is design number 5, that is 387. And the tube outlet temperature theoretically specified was 400 Kelvin, and the closest we get is the design number 4, which is design number 5, that is 382. So error is like 10% in the shell outlet temperature and 4.391% in the case of the tube outlet temperature. So this all you will get in this course.